Hey everyone, it's Mr. Wolfe here, and in this video I'm going to be going over the scientific practice of planning an investigation. All right, and this is going to include planning it, making your data table, but it's not going to include constructing the graph. So here's the scientific practice of planning an investigation, broken down into the success criteria needed to master the skill. So in order to plan an investigation, you need to be able to plan and identify your independent and dependent variables. You need to plan and identify certain parameters like your constant and control group. And you need to plan and identify how the data is going to be collected in a table and, for another video, displayed in a graph. All right, so this is one of my favorite quotes in science, and is so much of science is not in finding the answers, but asking the right questions. And this gets to the heart of science, that it's just fueled by this burning curiosity to generate questions that will eventually direct our experiments. So in the specific example we're going to be looking at in this video, it's going to be based on an experiment that I thought of while driving home the other day. I was wondering if something came up in front of me that I needed to react to. Right? Would it be different if the object was right in front of me, or if it was in a different place in my field of vision? In other words, maybe a side view. We would call this your peripheral vision. So my question is, what effect does your field of vision have on your reaction time? My field of vision is going to be my independent variable, and my reaction time is going to be my dependent variable. So your field of vision, or your independent variable, is your potential cause. This is going to be the variable that you're manipulating. Right? The way I like to think about it is you have the independence to have the object that you're reacting to in front of you, or you can make it towards the side. You have the independence to manipulate that. So in this experiment, and we're going to do this in classes, we'll have a computer program where there's a screen that's red, it turns green, and when it turns green, you have to press a button, and how fast you press your button, that's the reaction time. So we could have the screen that you're reacting to, right, in a side view, or in my peripheral view, in my field of vision, right? That would be my independent variable. Now I'm trying to see if my reaction time depends on where that object is in my field of vision. So that's why your reaction time is called your dependent variable. Right? This is going to be your dependent variable is going to be the possible effect. It's the variable that you're going to be measuring. So in this experiment, it's going to be the time to press the button on the computer program, right? And we're going to measure that reaction time in seconds. So in an experiment, you have to have an experimental group. And your experimental group is going to be the group that receives the treatment. In this case, it's going to be the group that views the sign towards the side, right, of their field of vision and their peripheral vision. Right? So you can't just have one group though. Right? You have to have some other group to compare it to, and many times that group is going to be called a control group. So a control group does not receive the treatment. Right? In this experiment, it means that the computer program or the screen that we're reacting to is right in front of us. Right? So why would we do this? The control group is going to be the baseline, which we could compare the experimental group to. So what that means is, let's say I run the experiment where I'm reacting to something in my peripheral field of view, and I react to it, and it's half a second. Right? I don't know if that's good or bad, right, on its own. Right? I would have to compare it to something. So maybe I would run the experiment with my control group, right, where I react to something right in front of me, and maybe it is 0.5 seconds. And then I would say, oh, well, there's no difference between whether it's in front of you or if it's in your peripheral vision. Right? But maybe I react to it here in front of me, and it's 0.25 seconds. It's like, wow, that's a huge difference. It definitely seems like having something in your side view is going to affect your reaction time. So that's what you always have to have, some group that you're comparing your experimental group to. All right. So in an experiment, you also need to have constants. And constants are going to be conditions you keep the same in an experiment. So in this experiment, it could be the same computer, the same distance from the screen that we're reacting to. All right. Whether it's here or here, it's still the same distance away. And maybe even the same time for a meal beforehand. All right. So why would you need to have that? Well, let's say, the reason why you have a constant experiment in an experiment is it allows us to know that only the independent variable is responsible for the change in the dependent variable. Right? So let's go with the example of eating a meal beforehand. Right? Maybe it wasn't a meal, but I drank a cup of coffee. Right? So let's say I have and I only drank a cup of coffee before I tested what my reaction time when the object was in my side view and my peripheral view. Right? And I didn't drink any coffee or anything beforehand when it was right here in front of me. So let's say I have a difference in time. It's a big difference in time. And I don't know if it was because the object was in my side view, and that's why I may have reacted differently, or because I had a cup of coffee, and that may definitely affect my reaction time as well. So because there's two variables and we don't know which one it is, we can't conclude anything with this experiment. So that's why you have to keep everything constant. Everything stays the same except your experimental group, except your independent variable. So if we do see a difference in reaction time, we know the only way that could be is because the only thing that changed was the fact that the object that we're reacting to is in a different field of our vision. All right, so that's really planning the beginnings of our experiment. Now what we could do is we can prep our data table before we run the experiment, before we collect the data. All right? So here's our starting data table. I'm going to skip ahead really quickly. This is what our data table is eventually going to look like. And I know that might seem overwhelming, so I'm going to backtrack to this data table because this is really the same data table. The other one I showed you is just a little bit more complicated, but it's still the same nuts and bolts. So what I mean by that is every data table is going to have kind of like an independent variable on your left and a dependent variable on your right, usually. Right? And then once you can make that, you can be like, all right, well, what is my independent variable? What is my dependent variable? Well, we already identified those, right? It's your field of view is your independent variable. Your reaction time is your dependent variable. Right? And for the field of view, well, you have a bunch of different types of fields of views that you're testing, right? Well, in this case, only two. So we're going to be testing the direct focus in your field of view, and then the side view, or your peripheral focus, right? Now, let's say that we measure reaction time, and it's only one trial, right? That may not be enough data to really be accurate. Sometimes we want multiple trials to really confirm that, yes, this is this person's reaction time. So the last thing that we'll do is we'll just take this data table and we'll expand it a little bit more to include multiple trials. That's it. Right? So now all I did, if you notice, we still have the independent variable, the field of view, right? The two different groups, experimental group and control group. We still have the dependent variable, reaction time. So it looks exactly the same to what we have right here. The only difference is I just split it into multiple trials, where I could do one trial with direct focus, two trials with direct focus, try a trial 3, a third trial with direct focus, and then I could average those out, and that's the number that I would take. And I could do the same thing with my other group, my peripheral focus group. Right? And that concludes it for planning.